Hello everyone, this is a course on General Aptitude for GATE 2026. In this session, we'll see the test of divisibility, HCF and LCM of numbers, condition of divisibility for algebraic functions. So, let's get started. Next, we'll see the test of divisibility. First is divisibility by 2. Divisibility by 2. Okay, let's take a number 72. Take the unit digit, that is 2. See if this unit digit is divisible by 2. Here this 2 is divisible by 2. Therefore, this number 72 is divisible by 2. Now we can take another number 64. Again, see the unit digit. 4. 4 is divisible by 2. Therefore, 64 is divisible by 2. Now if the unit digit is 0. Okay, 60. Here the unit digit is 0. Then also the number is divisible by 2. So, number is divisible by 2 if the unit digit is 0 or any other number that is divisible by 2. This is the divisibility test by 2. Next is divisibility by 3. Divisibility by 3. Okay, again we'll take a number. Let's take 2, 5, 5, 3. Now here add all these digits, that is 2 plus 5 plus 5 plus 3. We get 15. Now see if this number is divisible by 3. Okay, now 15 is divisible by 3. We know that 15 is divisible by 3. Therefore, this number 2553 is also divisible by 3. Now we can take another number, that is 131. Now add all these digits, 1 plus 3 plus 1, that is 5. Is 5 divisible by 3? No, 5 is not divisible by 3. Therefore, 131 is not divisible by 3. This is the divisibility by 3. That is, the number is divisible by 3 if the sum of digit in the number is divisible by 3. Okay, next we will see divisibility by 4. Third one, divisibility by 4. Let's take an example, that is 2652. 2652. Here, take the last two digits, which is 52. Is 52 divisible by 4? Yes, we know that 52 is divisible by 4. Therefore, this number 2652 is also divisible by 4. So, how to check the divisibility by 4? A number is divisible by 4 if its last two digits are divisible by 4. Only check this last two digits. If it is divisible by 4, then this whole number is divisible by 4. Next, divisibility by 5. Divisibility by 5. Let's take an example, 50. Here, see the unit digit. Unit digit here is 0. Another example, 505. Here, what is the unit digit? Unit digit is 5. So, if the unit digit is 0 or 5, if the unit digit is 0 or 5, then the number is divisible by 5. Only check if the unit digit is 0 or 5. If it is true, then this number is divisible by 5. Next is divisibility by 6. By 6. Here we'll take an example, 4, 5, 3, 6. 4, 5, 3, 6. Here what you have to do? Check if this number is an even number. Okay, first check if the number is even number. Yes, here this number is an even number. That is true. Now what we'll have to do? Take the sum of the digits. That is sum of the digits. That is 4 plus 5 plus 3 plus 6. What we'll get? 10, 15, 18. Okay. And is this number is divisible by 3? Okay, the sum of digit is divisible by 3. Therefore, this number is divisible by 6. So there are two conditions. Check if the number is an even number or not. Okay. Then add all the digits, and if this sum is divisible by 3, then this number is divisible by 6. So a number is divisible by 6 if the number is even and the sum of the digits is divisible by 3. So these are the two conditions for divisibility by 6. Now we'll see the divisibility by 8. Divisibility by 8. We'll see an example. 47472. 47472. Now take the last three digits, 472. Check if this number is divisible by 8. Okay, here we can see that 472 is divisible by 8. If we divide 472 by 8, what we'll get? 8 6 are 40, 8 5s are 40. Then 8 9s are 72. Okay, we get remainder as 0. Yes, so this 472 is divisible by 8. Therefore, this number 47472 is also divisible by 2. So, the condition of divisibility by 8 is if the last three digit of it is divisible by 8. Only check the last three digit is divisible by 8 or not. This is the divisibility by 8. Is divisibility by 9. Divisibility by 9. A number is divisible by 9 if the sum of its digits is divisible by 9. Okay, here 108,936. Now add all these digits, 1 plus 0 plus 8 plus 9 plus 3 plus 6. So what we'll get? 9 plus 1, 10. Then 18, 21, 27. Okay. This 27 is divisible by 9. We know that 27 is divisible by 9. Therefore, this number is divisible by 9. So, what is the condition? The number is divisible by 9 if sum of the digits is divisible by 9. Add all the digits and see if this sum is divisible by 9 or not. Next is divisibility by 10. Now a number is divisible by 10 if its unit digit is 0. Okay. Here, see that this unit digit is 0. Therefore, 90 is divisible by 10. Again, 900. What is the unit digit? Again, 0. Therefore, this number is divisible by 10. Only check if the unit digit is 0 or not. If it is 0, then the number is always divisible by 10. Next is divisibility by 11. Divisibility by 11. Let's see an example. 1, 3, 3, 1. Now what you have to do? Add these two numbers. That is 1 plus 3. Now add these two numbers. Again 1 plus 3. Okay, this is 4 and again this is 4. Now find the difference of these two. That is 4 minus 4. That is 0. Okay. If this difference is 0 or any other number that is divisible by 11, then the number is divisible by 11. Okay. Take another example. That is, okay, we can take another example. That is 1431. 1434. Okay. Sorry, 6434. Now take this two, add these two numbers, 6 plus 3, that is 9. Now 4 plus 4, that is 8. Now find the difference, that is 1. Is 1 divisible by 11? No. Okay, therefore this number is not divisible by 11. So for the divisibility by 11, the number, we have to find the difference of sum of digit at odd place and sum of digit at even place. And if we get this difference as 0 or any other number that is divisible by 11, then this number is divisible by 11. That is the divisibility by 11. Next is HCF and LCM of numbers. Okay, first we'll see HCF. Take two numbers, for example 16 and 40. Okay, what is 16? 16 is 8 into 2. Okay, 40 is 8 into 5. Okay, here the highest common factor HCF, that is highest common factor is 8. So HCF of 16 and 40 is 8. Okay, this is HCF, highest common factor. Now what is LCM? LCM is the least common multiple. For example, if we take two numbers 8 and 12. Okay, now we'll take the multiples of 8 and 12. Okay, what is the multiple of 8 and 12? That is 8 into 1 8, 8 into 2 16, 8 into 3 24, then 32, 40, 48. These are the multiples of 8. Now take the multiple of 12. That is 12. 12 into 2 24, then 36. Next is 48, 60. These are the multiples of 12. Now see which are common in these two. Multiples common in these two are, first is 24. 24 is common in both. Next is 48. 48 is common in both. These are the common multiples. Now take the least one. Least one is 24. Okay, among this the least one is 24. Therefore the LCM of 8 and 12 is 24. This is the least common multiple or LCM. Now we have seen what is HCF and what is LCM. Now we will see the LCM and HCF of fractions. HCF and LCM of fractions. Okay, first is HCF of fractions. That is equal to HCF of numerators divided by LCM of denominator. Okay, denominator. HCF of numerator divided by LCM of denominator. We will see an example. 1 by 2, 2 by 3, then 3 by 7. Take these three fractions. Now we will find the HCF of these three fractions. What is HCM of these three fractions? That is HCF of numerators. Numerators are 1, 2 and 3. What is the HCF of 1, 2 and 3? 1 is 1 into 1, 2 is 1 into 2 and 3 is 1 into 3. So the HCF is 1. Highest common factor is 1. So HCF of numerator is 1. Now we will find the LCM of denominator. Denominators are 2, 3 and 7. 2, 3, 7. And what is the least common multiple in 2, 3 and 7? Multiples of 2 are 1, 2, 4. Multiples of 2 are 2, 4, 6, 8. There are so many multiples. Now again multiples of 3. 3, 6, 9, 12, etc. Now 7 is 7, 14. Then 21, 28, 35. Next is 40 to 49, etc. So if we take all these multiples, we can see that 42 is the least common multiple. If we expand this list, we can see that 42 is the least common in all these. Okay, so 42 is the LCM of denominators. So HCF of this fraction is 1 by 42. So HCF of fraction is equal to HCF of numerator divided by LCM of denominator. Next is LCM of fractions. LCM of fractions. And LCM of fraction is equal to LCM of numerator divided by HCF of denominator. Okay. Now we'll take the same example. Find the LCM of 1 by 2, 2 by 3 and 3 by 7. First what you'll have to do, find the LCM of numerator. Numerators are 1, 2 and 3. 1, 2 and 3. This is the numerator. Now we'll take the LCM. Okay, one is, to find the LCM, we'll write all the multiples, that is 1, 2, 3, 4. These are the multiples of 1. Now multiples of 2 is 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, etc. Now multiple of 3 is Now multiple of 3 is 3 1s are 3, 3 2s are 6, 3 3s are 9. Okay, here see the common multiple. This is the least common multiple. Therefore, LCM of numerator is 6. LCM of numerator is 6. Okay, so LCM of numerator is 6. Now divided by HCF of denominator. Denominator is 2, 3 and 7. Find the highest common factor of 2, 3 and 7. So the highest common factor of 2, 3 and 7 are 1. Okay, so this is equal to 6. This is the LCM of the fractions 1 by 2, 2 by 3 and 3 by 7. So this is how we'll find the LCM and HCF of fractions. Next topic is condition of divisibility for algebraic functions. Here first we'll check, that is algebraic function a raised to n plus b raised to n. We'll check if a raised to n plus b raised to n is divisible by a plus b or not. Okay. Second we'll check if a raised to n plus b raised to n is divisible by a minus b. Okay. First we'll check these two. That is, here the condition is a raised to n plus b raised to n is divisible by a plus b only when n is odd. Here the condition is n should be odd. If n is odd, then a raised to n plus b raised to n is divisible by a plus b. For example, take n as 3, an odd number, that is 3. Now this is a cube plus b cube. What is a cube plus b cube? A plus b into a square minus ab plus b square. Now if we divide this by a plus b, what we'll get? We'll get as a square minus ab plus b square. So this is completely divisible by, so this term is completely divisible by a plus b. So the condition is n should be odd number. Again, a raised to 5 plus b raised to 5 is also divisible by a plus b, or a raised to 7 plus b raised to 7 is divisible by a plus b. The condition, only condition is n should be odd. Next is a raised to n plus b raised to n divisible by a minus b. So here a raised to n plus b raised to n is never divisible by a minus b. Never divisible. Whether n is odd or even. Whether n is odd or even, this a raised to n plus b raised to n is never divisible by a minus b. That is, if a raised to 7 plus b raised to 7, this is never divisible by a minus b, or any number. A raised to 6 plus b raised to 6, this is also not divisible by a minus b. So a raised to n plus b raised to n is never divisible by a minus b. Next we will check if third case and fourth case is a raised to n minus b raised to n. Okay, divisible by a minus b. First is by a minus b. Next we will check a raised to n minus b raised to n is divisible by a plus b. Okay, here a raised to n minus b raised to n is always divisible by a minus b. Always divisible. Okay, that is whether n is even or odd. That is, if n is 2, a square minus b square will be divisible by a minus b. Also, if n is odd, that is a cube minus b cube. This is also divisible by a minus b. So a raised to n minus b raised to n is always divisible by a minus b, whether n is even or odd. N can be even and n can be odd. This is always divisible by a minus b. Next is check if a raised to n minus b raised to n is divisible by a plus b. Here the condition is n should be even natural number. For example, take n as 4. A raised to 4 minus b raised to 4. What is this? A raised to 4 is a square whole square. B raised to 4 is b square whole square. This is of the form a square minus b square. That is a plus b into a minus b. A plus b into a minus b. Okay. And again we can expand as this is a square plus b square. This is again a square minus b square. That is a plus b into a minus b. So we have to check if it is divisible by a minus b. Okay. So if we divide by that is a plus b. Divide by a plus b. So these two got cancelled and we get this. So we can see that a raised to n minus b raised to n is divisible by a plus b only when n is even. This is the condition. So these are the condition of divisibility for algebraic functions.